common tangents to two circles. Common tangents to two circles are of two types. First we discuss direct common tangent. Now if the distance d between the centers C1 and C2 is equal to modulus of R2 minus R1, where R1 and R2 are the radii of the two circles, then the two circles touch each other. In this case, there is only one direct common tangent and can be found by simply S2 minus S1 equal to 0. That is, the radical axis of the two circles becomes the direct common tangent. If R2 minus R1 is less than d, that is the distance between the two centers, there are two direct common tangents, and the two tangents intersect on the line joining the centers. P divides C1, C2, that is the line joining the centers, externally in the ratio of their radii, as can be seen from the diagrams above. Thus, to find the equations of the direct common tangent to the circles, we find the coordinates of point P by section formula, as P divides C1, C2 externally in the ratio of R1 is to R2. Let P be alpha beta, then we suppose the equation of tangent to be y minus beta equal to m times x minus alpha. We find m by the fact that length of perpendicular from C1 is equal to its radius R1, or the length of perpendicular from C2 is equal to its radius R2. We get two values of m and consequently two equations of two direct common tangents. The second is transverse common tangent. If D is equal to C1, C2, that is R1 plus R2, the two circles touch each other and there is one transverse common tangent at their common point, which can be found by S2 minus S1 equal to 0. If D is equal to C1, C2 is greater than R1 plus R2, there are two transverse common tangents which intersect on the line joining the centers. Let the point of intersection be P alpha beta. P divides the line C1, C2, that is the line of centers, internally in the ratio of their radii R1 is to R2. We then assume the equation of the transverse common tangent to be y minus beta equal to m times x minus alpha.